Good morning. Today we're going to be talking about two-step mole conversions. Last week you practiced one-step mole conversions, going from grams to moles and back, and going from moles to atoms and back. Today we're going to combine those two steps. Okay, we are still going to be using our conversion factors of 1 mole is equal to the molar mass, and that's when we have grams. Okay, use this conversion factor whenever your problem involves moles and grams. And we're going to be using 1 mole is equal to 6.02 times 10 to the 23rd atoms, particles, or molecules. Okay, this is the conversion factor that we used whenever our problem had moles and atoms, particles, or molecules. Okay, today you're going to need to go ahead and go to this page in your packet, Grams and Particles Conversion Worksheet. You are going to need a periodic table and a calculator. So if you don't have those, go ahead and get them. Okay, so grams and particles conversion worksheet. When you look at this page, it talks about some of the stuff that we talked about last week. Okay, notice right here it says, how do you choose which conversion factor to use? Look at what you were given in the problem. All right, always look at what you're given in the problem. And then you select conversion factors that correspond with what you've been given. And I'm going to show you what I mean by that. So in this first example problem, it's already solved for you. It asks you how many molecules, so molecules is what I'm looking for. How many molecules are there in 24 grams of FeF3? So 24 grams is what you are starting with. Now, do you have a conversion factor that allows you to go from grams directly to molecules? And if you're not sure of that answer, we're going to look back at our conversion factors. These are our two conversion factors. Notice we do not have a conversion factor that says grams equals some number of molecules, atoms, or particles. So we cannot go directly from grams to particles, atoms, or molecules without first going to the mole. This is why this is a two-step problem. Okay, so anytime you start with grams and have to go to atoms or molecules or particles, or if you start with atoms and have to go to grams, it's going to be a two-step problem. The mole is kind of the bridge between grams and atoms. Okay, so in the problem that is already worked for you, you always start with what you've been given. So you've been given 24 grams of FeF3. So we use the conversion factor here of 1 mole is equal to the molar mass. And if you're not sure about this, I will label it. This is molar mass down here. Specifically, this is the molar mass of FeF3. And we know that 1 mole is equal to the molar mass. So that gets us from grams, now we're at moles. Okay, but we don't want to end up in moles, we want to end up in molecules. So we have to use our other conversion factor of 1 mole is equal to 6.02 times 10 to the 23rd molecules. Notice where I put the individual components of that conversion factor. At this step, I'm in moles, but I need to get rid of moles. So moles have to go on the bottom. So 1 mole goes on the bottom. And then we said what I'm trying to go to always goes on the top right-hand corner. I'm trying to get to molecules, so molecules have to go on top. And anytime that I use molecules, I also use Avogadro's number, 6.02 times 10 to the 23rd. In order to actually solve this problem, you do like you did before. We're going to multiply completely across the top. So 24 times 1 times 6.02 times 10 to the 23rd. And then you're going to divide by the bottom. Okay? And some people like to tell you that you need to multiply across the top, get a subtotal, multiply across the bottom, get a subtotal, and then divide. Because order of operations, you have to do the multiplication down here on the bottom first, and you may not always have a 1. Okay, so we are going to go ahead and do example number 2. Notice it asks us how many molecules are there in 450 grams of sodium sulfate. So I'm starting with 450 grams of Na2SO4. And I'm trying to find molecules. So we are going to set this problem up exactly like this one up here, because we are asked to find molecules and we're starting with grams, same as we were up here. Okay, we're going to go ahead and start with what we've been given, which is 450 grams. So I'm going to go ahead and write that down. 450 grams of Na2SO4. And it's a two-step problem, so I'm going to go ahead and set up my framework, and I'm going to draw 2 lines. All right. Now I'm starting with grams, so I have to get rid of grams. So I know that grams of Na2SO4 is going to go down here, and this is going to be our molar mass. And 1 mole is going to go on top, because again, we're using our conversion factors. And I know that 1 mole of Na2SO4 is equal to the molar mass of Na2SO4. We'll come back and we'll find the molar mass in just a sec. Now again, I'm at moles, but I need to get to molecules in order to answer my question. So I'm trying to find molecules, which means molecules has to end up here on the top right-hand corner. So I'm going to go ahead and write in molecules. And then on the bottom, in order to get rid of moles, I have to divide by moles. The number that goes with moles is 1. And the number that goes with molecules is Avogadro's number, 6.02 times 10 to the 23rd. Now that we've set up our problem, we're actually going to solve it. We're going to, oh, no, sorry. We have to come back and find molar mass. Okay, so in order to save time, I calculated the molar mass of sodium sulfate, and it's 142. Y'all can check me and make sure that my work is correct. Now we're going to go ahead, we're going to multiply completely across the top, multiply across the bottom, and then divide. If you want to, we can get subtotals over here and then do the division, or you can just type into your calculator. I prefer to type it into my calculator using parentheses. So I'm going to go ahead and show you that. So I'm going to do parentheses for what's supposed to be on top, 450 times my 6.02 times 10 to the 23rd. Close parenthesis, because that's what's on top, divided by 142, because that's what's on the bottom. So my answer is 1.9, and we're going to round this up to 1. 1.91. That E means times 10 to the 24th power. So over here, I'm going to go ahead and write down 1.91 times 10 to the 24th power molecules of Na2SO4. Okay? Now we're going to go ahead and look at the next one. So that's how you're going to set up your problem if you're starting with grams and going to molecules. The next one, they ask you, how many grams are there in 2.3 times 10 to the 24 atoms of silver? So you're starting with atoms. And you're being asked to find grams. You're basically working in reverse. So again, you start with what you've been given, which is 2.3 times 10 to the 24 atoms. You use the conversion factor with Avogadro's number of 1 mole is equal to 6.02 times 10 to the 23rd atoms. Remember, what we're trying to get rid of, that's going on the bottom. So I'm trying to get rid of atoms, so atoms has to go on the bottom. 1 mole goes on top. Now I'm at moles, and I need to get to grams. So I put the molar mass for silver, which is Ag, and it's 108 grams on top, because that's what I'm trying to find. And I divide by 1 mole, because we have the conversion factor of 1 mole is equal to the molar mass of a substance. Notice how they've actually canceled out the atoms. You divide by atoms, and then they've canceled out the moles. And you're only left with grams. That's showing that we're in our correct units. And they wrote the final answer, 421 grams of silver. Or you could write 421 grams of Ag. Okay, we're going to do the next problem, which is going to look like this. So, in problem number 4, they ask you how many grams, so that's what you're trying to find, are there in 7.4 times 10 to the 23rd molecules of AgNO3. So we're starting with 7.4 times 10 to the 23rd molecules of AgNO3. Okay, so we're going to go ahead and write down what we've been given, which is 7.4 times 10 to the 23rd molecules of AgNO3. I'm going to go ahead and draw my little framework. And I know since I'm going from molecules to grams, and I don't have one conversion factor that allows me to do that, it's going to be a two-step problem. So I'm going to go ahead and write 2 lines here. Okay. Ultimately, I'm trying to get to grams of AgNO3, so we're going to go ahead and just write that in our top right-hand corner. Grams of AgNO3. Now, in order to get there, I'm starting in molecules, so I have to get rid of my molecules. Whatever we're trying to get rid of goes on the bottom. So molecules is going to go right here on the left-hand side on the bottom. Molecules, AgNO3. And then we have a conversion factor that allows us to go from molecules to moles. So moles goes up top. Now I'm at moles. I need to get to grams. In order to go from moles to grams, I have to divide by moles. So moles of AgNO3 goes down here. And we said grams is what we're trying to find, so that goes up top. Now, how we determine what numbers go in which slot? We said anytime that we write the word molecules, okay, the only number that we know that is associated with molecules is Avogadro's number. So we're going to go ahead and just write 6.02 times 10 to the 23rd down here. And then we know that 1 mole is equal to 6.02 times 10 to the 23rd molecules. So 1 mole is going to go ahead and go on top. On the far right-hand side, we also have a conversion factor that says 1 mole, so we're going to put 1 in the bottom, is equal to the molar mass of a substance. So we need to calculate the molar mass of silver nitrate. I've already calculated it, and I can tell you it's 170 grams. And feel free to check my work. And then we are simply going to plug this in. Okay? So I have... parenthesis. I have 7.4 times 10 to the 23rd power multiplied by 170 divided by 6.02 times 10 to the 23rd power. Okay? Notice how I put what was on top in parentheses. So that way it's being multiplied first before it's divided. Let me hit enter. So our final answer should be 208.97 grams of AgNO3. So we'll go ahead and write it down. 208.97 grams of AgNO3. Okay, so today you are going to complete the back side of this page. All right, 5 through 13. All right, and just make sure that you look at what you're starting with on each problem and what you're going to. Because notice, these are all molecules to grams, or grams to molecules, molecules to grams, grams to molecules. So you're going to be splitting these problems up like one of these 2 examples that we just did. Okay, so if you're not really sure, go back up here and look and see how they set up a similar problem, or how we set up a similar problem, and mimic the steps. Okay, just filling in the correct number for your molar mass. But anytime you have molecules, atoms, or particles, you're going to use this number right here. Okay, I will be back on Tuesday, so I'm sure you'll have a lot of questions. Make sure that you come with these assignments complete, so that way we can look over it and see what you've done correctly and where we need to spend more time. Okay, have a good day.